Welcome to this revision series video. Today we are going to talk about a couple of things. Now, these are one of the most important interview questions you can get around JavaScript, be it for SD1, SD2. The topic is around closures. Now, this is a pretty large topic and you can get variety of questions around it. Okay, so let's see what all we'll be covering in this. So we'll be looking at what are closures as such, why do we need to use them, what is currying, some applications around it, and some basic gotcha moments about um, closures itself. Okay, so what are closures? It is basically a mechanism. Now, there are many ways to explain this. I'm just trying to explain my own words. It is basically a mechanism in which JavaScript maintains scope of some variables in closures or in a closure scope if the particular um, variable goes out of scope. Now it's very important to understand this is only kind of works with functions. Okay, so if a function basically is being executed at some later point of time, and it is trying to refer some variable which goes out of scope. At that point, JavaScript will put that in a closure scope. Now, this is kind of determined in the during the execution phase as such, or we know JavaScript is a two-pass engine. So it kind of decides at this point how is this going to be decided, and this is called basically the lexical scope, where it matters more on where your functions are declared. And based on this, it will decide how the closure is going to be maintained. Now, this is something that is done during author time or while the creation phase or when you run the program initially, not during runtime. All right, not during runtime, it doesn't change that way. This, for example, you can change the context of this during runtime, but lexical scope is something we maintain around that. Now, let's take an example of what I mean by this. Now, one of the most common examples is that we have a simple function. We can just call it outer. Okay. Let's define a variable, let's say a equals to 10, and let's return a function inner and return, let's say a, and let's say inner take some value. Okay, and I can say b. Now, what happens if you execute outer? So I can say is var fn equals to outer. This basically will return, the return statement of outer is basically inner. Okay. So this return statement basically holds this inner function. Now, if you think about it, technically this variable a supposed to go out of scope because we have returned this function. But if we invoke, let's say, function here, we will get an answer 20. Now, if I change this to 0, give you 10. So you can see how the value is actually changing based on the value I changed in the function here. So what is happening is that the value a is actually being kept in a closure scope. Now, how can we kind of see this in like, how can we see this? So let's do something. So let's just open the same example in VS Code and let's open up our Chrome developer. Okay, so this is inside your sources and index.js. Let's just add a breakpoint over here. And let's run this again. So, or let's add one more breakpoint here and let's run this. Okay. So right now we are at this particular stage where we have this outer function where we are invoking it. And let's step into the next one. So we can step into it. Now we go and define a variable here. So you can see that a is undefined. This refers to the window at this point. Let's see the next step. At this point, we are returning a new function. Okay, we're not invoking the inner, we're just returning the inner. So we do that and we're done. And line number 10, we are actually going to invoke the inner function that we return, which we stored in line number 8. And this is going to basically print again. Right now, at this point, you can see that we are inside this line number 4. We have B and we have A. Now, if you look at your scopes, you have a local scope, which is B, and this refers to window. But you can see that there is one more scope which comes into play, which is the closure scope. And this is from the outer function. And it says, hey, there is a variable called A, which is 10. So at any point, the value of that A function is kept internally, and we are referring to this closure scope. So this is a very common example. Now, it is also possible to write in terms of outer, in this case, and put a value here, right? And let's put A is here, right? I can put now 10 plus 10 becomes 20. We put 20 here. It is basically adding those two values now. So the term closure is actually from mathematics. We're not getting into that part. But this, the way of writing this code, this is technically called currying. It is a functional programming way of writing code where we can wrap around a function, we can privatize some variables, and we can pass some information to another function. So this is used in many places, especially around Node, or if you're looking at Redux, for example, when you work with connect component. Okay, it is a higher order component. So it is written in this form here. This can also be used in backend when you're working, maybe when you're importing some your servers, or maybe importing some WebSocket as such. We would kind of invoke it first, and then we would pass some reference of the server into it. Okay, so this is a very simple example of closures. There are other ways to go about this also. Now, let's take another example of a calculator. Okay, initial value, and I can decide some initial value, and I can say var a equals to initial value, or value equals to this. So at this point, I can have I can return a set of functions that we can work with this. For example, I can say add. Okay, this can take some val, right? And I can modify the value with value plus val, return value. and I can return this function with it. So I can say calculator equals to calculator in this form. I can directly pass this. Now, if I try to do a dot operator on the calculator, you can see that it adds something and you can pass some value into it. So you can see that you get um, a value of 10 over here. If I were to make it another 10, you can see that it remembers the previous value. So one of the use cases of closures is that we are able to maintain the state internally. We are able to remember the previous value. Now this comes into a lot of applications where it's useful. Because of the fact that you can remember the previous value, it's sometimes referred to as memoization. All right, this is useful. I mean, maybe you want to calculate the prime number of uh, you want to calculate prime number, or you want to keep a value of the previous values that you have. You can do some kind of memoization. Now, a couple of examples of applications around closures are debouncing or throttling as such. Why are these important? Because we are basically applying memoization to debouncing or throttling. We are keeping we are keeping in memory of some information of when was the last time I had called this particular function.